We have Derek Thomas speaking next. He's a senior information security consultant at eCentire. So give it up.
Thanks, guys. Oh, we got a packed room coming out after lunch. I'm impressed. Hopefully we can keep you awake here. So my name's Derek Thomas. We're going to be talking about just security baselines, kind of fundamental application of statistics and analysis for logs and determining upper and lower thresholds on your log data. Look kind of for funny stuff. So start off with who am I? Derek Thomas. On Twitter, I'm DTom. That's with a 0. So if you want to say hi anytime. I'm basically a family guy. I'm a security consultant with eCentire. My domain knowledge has been in log management SIEM. So for almost my entire security career, I've been doing SIEM implementations with pre-sales, post-sales, ongoing services, things like that, with several different vendors. I've also done vulnerability management, and I kind of, from a theoretical standpoint, try to stay up with different pen testing techniques. I mean, I think if you're going to be a good blue teamer, you got to understand red team. If you're going to be a good red teamer, you got to understand blue team. So I think both of those are kind of critical. So I'm a lover of logs. If you know me, I've probably bored you to death on numerous occasions with, talking about Windows security logs and network hardware logs. So I primarily with logs, I focus on threat detection. I like logs because they tell you everything that's going on in the environment. You can see everything a user does, and that's really the definitive activity for that user. So once there's once there's been a compromise, that's what you're going to be going to. And I consider myself an armchair data analyst, so I'm trying out my skills. I think that's going to be critical if you're in the same field with log management and SIEM. You're going to need to be able to kind of start applying advanced analysis to the log data. We're getting to a point where there's ridiculous quantities of log data. I think in my day-to-day life, I've got over a petabyte of compressed logs to work with across all our clients. So it's kind of impressive to me. So day-to-day, I manage log management sensors. So I'm in Linux command line interface, Python. Somehow I got Miyagi'd into learning SQL. So I never touched SQL, but become pretty decent at querying and extracting data. And I've been studying R on my own. I think that's going to be one of a pretty good language to do this type of analysis, and most of the things you need are built in. I volunteer with ultimatewindowsecurity.org, so if you're familiar, if you've ever looked for Windows events, that's probably the first thing that comes up. There's tons of great content for Windows logging. Active in the Michigan InfoSec community. I see some MySec people out here, so let's give a shout out to MySec. And in my previous life, I was a blackjack dealer, so I'm kind of came home here. So if you want to talk about card counting or anything, that's kind of a fun fact afterwards. So word of caution, I heard Ken Weston say he's not a data scientist. I heard a couple people say that, so I'm definitely not. I've been trying to up my game and apply these concepts to log data. And this presentation is kind of the application of my research into the data that I work on a day-to-day basis. And their experiences have been pretty good so far. Clients will often ask us, hey, I want to see weird stuff happen. And if you're like me, if you're generating use cases, you're like, well, what does that mean? When you're generating use cases, you need clear defined events and alerts that you want. So this is one way that you can hopefully answer that question. So we're going to be focused on just obtaining kind of practical results. You can apply these concepts in Excel if you want, Python or R or SQL, whatever you have at your disposal. You should be able to apply these concepts. Covering the agenda, I'm going to talk about why I'm giving this presentation, what I'm hoping you get out of this presentation, why I like internal log data. I see a lot of external data, web data, DNS data, but I haven't really seen much in operating system. Why determining normal is important, what a baseline is, getting data and exploring it, investigating it, and then finally kind of creating those thresholds, running through a use case methodology, and we'll probably go through 2 different use cases, and then I'll follow up with some resources and references. So I feel that log data is highly underutilized when I talk to people. There's not that many I find in security monitoring. How many people here operate or use log data on a day-to-day basis? So I'm in good company here. It's not normal. I don't normally find that at other conferences, so I like to see that. But I find that there's very little defined approach to using log data. Like, when I'm doing implementations for SIEM in my previous life, you would implement it, and then the clients say, now what? Well, you got to define what you want. You got to figure out what's valuable to the company. So I learned way too much the hard way, and so hopefully this will be one of those things I can help you guys with. And the main reason is when I was looking through best practices in the very beginning, everything says look for normal activity, look for trending, but nothing ever says how to do that. Has anybody ever seen really how to determine a trend? Really it's visualize it and say look for this spike, but sometimes that spike is normal and it may not be something you need to investigate. So I find there's little coverage with security data analysis pertaining to Windows logs and network data. So I'm hoping to kind of cover that gap or that perceived gap. So I'm trying to provide practical strategies. So like I said, if somebody implements this in Excel, I'm going to consider it a success because I think that's awesome. I do everything in R or SQL, but hopefully you can do it in anything that you're familiar with. So we're going to cover methods that are easy to understand and describe. That's really the goal. I mean, this is straightforward, but you need to be able to describe this to the stakeholders in your organization and say, why is this important and what's going on? There's some really cool stuff with deep learning, but to describe that to clients or management, how are you going to do that? There's a lot. Sometimes things are perceived as a black box. So hopefully this is one way that you can easily illustrate kind of anomaly detection techniques. So like I said, this can be implemented in Excel, Python, R, SQL, etc. So kind of cover this. I see a lot of content on DNS logs, firewall logs, NetFlow, web logs. I don't see on Windows logs. Windows tells you everything that's going on in your environment and everything a user has done. So I think that it's very valuable. So why is the importance of normal? Has anybody here been asked to determine what's normal or try to trend data or create baselines? So yeah, if you Google log management best practices, everything says that. So hopefully this will be a tool for that. So beyond just kind of like alerting on thresholds, there's also a tool for proactive investigation, or some people call it hunting. So I've seen that frequently, looking for deviations in traffic in an unknown data set, so that you'll be able to use this to go back in time and look if anything abnormal happened during that time. Aids in investigation. So from time to time I've been asked and said, Derek, I just looked at this report. There's 1,700 authentication failures. Please investigate that. Well, the first thing I do to say, is that normal? Every single day there could be 1,700 authentication failures, and yet the users are unaware. So this is a tool that you say, well, yeah, this happens every day. On average, it happens this amount of time, and it'll increase or decrease by X amount based on the deviations. So, and it can also help you understand your environment. So if you got into a new environment, you could apply these techniques to kind of see what's going on. So as security professionals, and specifically as security monitoring professionals, I have had very little ability to affect change in terms of like policies and things like that. So you can understand, well, it might be normal for users to RDP into all your servers, right? It may not be best practice, but it happens and I can't change that. So this is one way to monitor that type of activity. So we'll talk about baselines. So like I said, best practices always state look for trends and abnormal activity. So here's an example of just aggregated Windows event count per hour, right? You see a significant spike at 6 o'clock. But, is that a trend? Is this even abnormal? And really, what is normal? So those are the things we're going to tackle. So looking at these, you can see that at first it might seem like there's a significant spike and something's going on that's bad. But as you go on, you see that's happening every day. So either that's normal activity or you've been pwned and this has been going on for a very long time. So what is a baseline? I kind of give a fundamental definition of just, it's a measure of the normalness of some set of data, right? I try not to get too technical with these. Down here is a reference to, I pulled this from a book called Logging and Log Management by probably the godfather of security monitoring, Anton Chvakin. So that's a great book. It's kind of hard to get through. Log management's not the most electrifying thing to read through, but it's definitely valuable in my opinion. So we're going to talk about baselining, and in particular baselining events that kind of follow a normal distribution. What I found is that a lot of the data that we look at will be approximately normal. And if you're not familiar, the normal distribution really just means that on average, activity will occur near the average. And as you go farther out, either up above or below that account, the probability of that occurring will be less and less. And if it follows a normal distribution, you can see that with 68% of the time, it'll fall within one deviation above or below the mean, and 95% of the time, one or two standard deviations above or below the mean, and then 99.7, three, give or take. So we're going to be using this data to create our thresholds after we've determined that the data is approximately normal. So what types of things can you baseline? Really anything that occurs on average and will deviate, above or below the average kind of equally. We gotta have good symmetry. So things like event rates, which we'll talk about, authentication failures, maybe bytes transferred in a VPN session could be good candidates. The first question I always get is, what about non-normally distributed data? Well, there's other techniques for analyzing that. I'll probably show a tool at the end called Twitter's anomaly detection for non-parametric data, but we're going to focus on normally distributed data and creating thresholds and analyzing that. So we're going to start with the Windows event rate. So Windows event rates, it's really exactly what it says, the quantity of events that are coming in. So it's often measured in events per second. We aggregate in events every 5 minutes, could be events per hour, per day, whatever you want. So basically event rates in your log management system, it's probably not going to catch an APT, right? Like an APT is not going to be generating a million events that don't normally occur. They're going to try to create as little as possible to kind of fall in with normal traffic. But I still think it's extremely valuable for things like determining log sources that have failed, determining scripts that have gone haywire, like maybe the password's changed on a script on an admin's desktop. Maybe there's operational issues. You can't catch an APT if you're not logging, and if your agent on the domain controller failed, and you don't know it, that could be a significant problem once that data starts to roll over. And also, you may think you're logging, but you're not due to audit configuration. So maybe you don't even produce logs for login failures. So here's an example. Some people may or may not be familiar with Windows. This is a standard Windows log. You can see that. There's a little diagram. We transmit data typically through syslog. Windows has Windows Event Forwarding. There's many ways to get the data. But most log management systems, SIM systems, will measure the events per second because they use that data to determine, are we overloading the system? They usually have some sort of specification to say, we can handle 10,000 events in a second, or we can handle 3 million events, surges, and things like that. So obtaining this data is probably the most difficult thing I talk about. I think in data science and data analysis in general, I think getting and cleaning the data is probably the most difficult from what I'm told. But like I said, most systems will have that. Here's an example. This is ELK measuring events per second. This is a SIM right here measuring events per second. And if you don't have either of these systems, you could look at a custom application using a graph, a metric server. So StatsD from Etsy as a way like Logstash can output to StatsD. So if you can start counting your events and visualizing and analyzing them. So data available to me was aggregated into 5-minute periods. So I extracted that data, pre-processed it in Postgres, and I wasn't sure what I was looking for. So you see, really the data started off with just a timestamp, a Windows count, and a syslog count. But I extracted the day of the year, the day of the week, the hour of the day, because I'm not sure, as we started to explore the data, what we're going to be looking at. Are we going to be comparing specific hours of weekdays? Are we going to be comparing full days against all Mondays? Or are we going to be comparing weekdays to other weekdays? So those are things that we're going to find out. But basically, the data is all just a comma-separated format with integer quantities for event rates. So before you start, you always ask some questions. And especially for these baseline, you're going to be asking, is this data approximately normal? That's going to be the big one for developing statistically relevant thresholds. You can always just calculate standard deviations and add it and subtract it, but it may not be statistically relevant, as we'll talk about. So if the data is not normal, can you make it normal? So can you subset the data? Like with this, I'm going to assume that weekdays and weekends are probably going to get far less data. So that would skew your data, and you may have to model those separately. And are there anomalies within the data set? So once you look at the data, is there extreme anomalies that you're going to have to deal with? And we'll talk about how to do that. So the first thing I did was visualize the data. These are the quantity of events that occur per day. So you see that there's kind of most of the data occurs right here. Then you see 2 sequential days far below. So first thing I think, those are weekends, right? Because you're going to say typically the traffic is going to be lower because there's not many people. There's going to be automated processes always generating events, so there will always be events. So those are a few things that I immediately look at. So the data was probably skewed due to weekends. There appear to be several outliers. So down here, this one's extreme. And we'll talk about this one in a minute. But then also when I look at these, are there any other patterns that you see here that might be considered kind of a local outlier? Does anybody see it? Yeah, right here. So you look at that and you say, okay, there's 2 sequential, but here there's 3. So let's talk, well, that's something we need to look at. And that's the first thing that I queued up to when I was looking at this data set. But when I look at the weekdays, so I think these are weekdays, the data looks to be, based on this graph, could be normally distributed. You see it's usually happens around this. Sometimes Mondays are lower, sometimes they're higher, sometimes Tuesday's way high, and sometimes it's lower. So there seems to be a decent distribution above and below.
Could your first cluster be a holiday weekend?
That's a great point, and you're absolutely right. So that right there is actually Good Friday. So it's a stat holiday on that one. So I'm going to take a look at that, and now I'm going to color code the weekend. So now we definitely know that this is the weekend. So this is Saturday and Sunday. This is a Friday. So I took a look, and that day is the 85th day of the year. So I took a look, and that's Good Friday. And they happen to have a stat holiday for Good Friday. So this is far lower than what we would normally experience. This down here is something that needed to be investigated. What's going on here? This is what we're going to be looking for. We want to see when things like this happen. And what that was audit configuration. So they didn't have the proper audit configurations enabled. So they weren't getting anywhere near the log data that we needed to be getting. And once they enabled that, it turned on. And they were trying to get this done before Good Friday, I think. So there's 2 possible outliers. We need to figure out how we're going to handle them. I find that within the data science community and statistics community, handling outliers seems to be kind of a really tough debate. How, do you get rid of it? Do you keep it? But I think that in these cases, we want to get rid of them, especially this, because this is not normal traffic. So we don't want to use this to base our baselines off of. It's not like this was a naturally occurring because there's a big project and everybody's working and that's generating a lot more events. It was just strictly due to a technical deficiency. And then this is a holiday. So I definitely, when you're doing something like this, take a look and say, do we even want to include stat holidays? Okay, because those are going to be lower. That's going to be a choice that's up to you. And really the worst case scenario is that this would be an alert that day. Do you have people that would even respond to an alert on a stat holiday? If no, I would definitely get rid of it. There's really 3 different methods to dealing with outliers. So excluding it, which is trimming. There's Winsorizing, which is replacement. So you could take the average Friday and just replace that value with the average Friday. You could also just keep it. So if it's a naturally occurring outlier, I would definitely keep it. Like you just really have a lot of people working hard and doing a lot of administrative activity. That's naturally occurring, and that should probably stay within the data set. So we're still kind of going through the exploratory data. We think this could be normally distributed. It's impossible to tell from this graph alone. So we'll take a look. We're going to look at the histogram. So the histogram will bin the data into groups and tell you the frequencies. So in a normally distributed data, you're going to see some symmetry around the median. But here you totally see the skewed data due to the weekends. So this is including the weekends. So after removing the weekends, we see a little bit better data. There's a little bit better symmetry, but there's still that Good Friday outlier. Again, I'm going to remove that, take a look. Now we see the data looks much better. We still think it could be skewed here, but again, we're only looking at about 30 data points. So this is a sample. The data is never going to be perfectly distributed. We need to find out whether it's acceptable for our analysis. So I'm going to talk about a couple of techniques for looking at the data and determining if it's normally distributed. So the first one's called a QQ plot. Basically, that maps the data versus the theoretical quantiles. And the only thing that I need to know is this data following this line? If it's close to this line, it has a better chance of being normally distributed. We do see on this data that there's a few points where it starts to stray off. So this looks like it's pretty good. I have a better feeling that this is normally distributed, but I'm still not totally positive. You'll never be totally positive. We're just trying to determine if this is approximately normal so that we can create upper and lower thresholds using the statistics of normal distributions. So the next thing I did is I said, well, what does a randomly generated normal distribution look like on a QQ plot? So I took the mean of the data set, I took the standard deviation, and I pumped it into R norm using R and generated this data randomly. So randomly, absolutely taken from a normal distribution, it looks like this. And you see it deviates a little bit, so this makes me feel a little bit better about the data. You see that there are a few points that are straying from the line. There's still only 30 data points. We see similar deviations. So I feel better that this is normally distributed. And you can see comparing them directly. But this is still a visual interpretation. It's up to your judgment, and a lot of this will be. Much like outlier detection, with outlier detection, there's no specific guidelines for determining what exactly is an outlier and how to handle it. But finally, we're going to take a look at another test. This is the Shapiro-Wilks test. So the Shapiro-Wilks test is available in R, but you can also, I've seen it done in Excel. It's available in multiple packages. So what this does is really just feed it your list of quantities. So that was the list of all the events through the data set that we had. Feed it into the function Shapiro.test, and it outputs a p-value. And what that p-value tells you is that if this is over 0.05, there's a possibility that this was taken from a normally distributed data set. And the higher this value, the better that possibility is. If it's below 0.05, we would have to exclude it from being normally distributed. So we've determined that the data appears approximately normal. We're going to be going through the exercise of baselining weekday non-holidays. You're going to have to analyze the weekend data separately. You go through the similar methods, but you'd have far less data because you'd have to use 15 weeks worth of data to collect that. So the thresholds are going to be calculated to determine surges and dips in the value. So we're going to use this data to create the thresholds. So here I've rescaled the data. You see this red line is the median. That's the average value. You can kind of see above is about the same amount of events as below it. It looks pretty evenly distributed. You see, to me, it looks like there's more in this band, and as you go farther out, there's less. So we're going to take a look at calculating the deviation in this data. Kind of basic statistics, the standard deviation measures the spread. So here I have lines for 1 standard deviation, 2 standard deviations. And what we see is that 64% of the data is within 1 standard deviation, 97% is within 2. And I've provided a couple examples of how you can calculate this. So in R, SQL, Excel, pretty easy. It's a base mathematical function. So going back to our normal curve here, we see that 68% of the data should be within 1 standard deviation. Our data's got 64, so we're pretty close. And you got to keep in mind this is a sample from real data. We see 97% within 2 standard deviations. That's pretty close to our 95% thresholds. So I think we're pretty good. We're pretty close to what they call this the 3 sigma rule. This chart illustrates the 3 sigma rule, which is kind of a base property of normal distributions. So for me, creating thresholds, 2 standard deviations works pretty well for those thresholds. And you can say that 95% of the time, data should fall within that threshold. And after that, that would be somewhat anomalous. You could use 3 standard deviations, again, depending on your use case. So for the example of events per second, usually when there's significant deviations, it's major. Like audit configurations have stopped. Network configurations are blocking syslog. Those are things that will cause significant drops. So depending on the use case, you might want to use 2, maybe 3 standard deviations. So we're going to talk about baselines as a use case. I think this was kind of a fundamental topic through all the ground truth tracks too. I hear a lot of people talking about use cases. When it comes to security monitoring, I feel probably one of the best things you can do is create well-defined use cases. I hear a lot of complaints, and the answer to most of those complaints with any SIEM that anybody has ever used, I think could be solved with a well-defined use case. So we're going to walk through another baseline example. I pulled this example from threathunting.net. So if you're familiar with threat hunting, a couple of the people that are very well known have created a GitHub repository for successful hunts that they use. And one of these hunts utilizes Windows logon events for detecting lateral movements and RDP external access. So that's what we're going to talk about as a pretty good security relevant example. Also, what I like about threathunting.net is some of the techniques rely on baselining and outlier detection. So both are very applicable to what we're doing right now. So if you're not familiar with RDP, it stands for Remote Desktop Protocol. So if you want to log in from computer A to computer B and have a GUI interface to that computer, you can use RDP. That produces an event. It's a 4624 Windows Event ID of type 10. The type 10 indicates interactive logon or remote interactive logon. And that's what we're going to be using for collecting this data. So we're going to baseline RDP access within the environment. RDP access could be used for administration, could be attacker movement, like I said, lateral movement, but it could be excessive connections from a new administrator. RDP should not be necessary for most administration activities, from my knowledge, but I find that it is often used for that. So this is a good use case because administrators will use it, but may not be maliciously. So we'll cover kind of the use case primer. Applying this use case to not just baseline to anything you do within log management, I think is critical. So I've pulled this from a resource called InfoSec Nirvana. They kind of outline a good methodology. There's a great, I think it was a stable talk at DerbyCon last year or 2 years ago. It's pretty quick, 30 minutes. This is a very in-depth, intense use case walkthrough. So it provides documentation, tracking use cases as they go on, and measuring new use cases as you create them. Use cases follow, I think it's an 8-step kind of program. So we start off with developing the requirements of the use case, defining the scope. So what's this use case going to apply to? Your whole environment, a remote office, specific assets, things like that. Then what event sources are going to be needed for the use case, and do we have that data? We're going to validate that the use case is feasible. So in our case, we're going to look at determining whether the data is normal, what logic we're going to use for generating the outputs. So when do we send you an email? When do we send you a report? When do we create a dashboard event, et cetera? Then we're going to go through implementation and testing, the actual response to the alert. So one of the biggest things I get is, okay, I see these alerts in the dashboard, Derek, but what do I do now? So defining that is critical, and then ongoing maintenance. The first step is defining the requirements. So requirements are really a high level. Why are we doing this? So we're either doing this to enhance security. Another one might be compliance or regulatory, or maybe it's a business use case of enabling availability so that a business process can occur. So for me, RDP access probably falls into security and compliance. PCI requires monitoring authentication, remote access to systems, and it's also just a good housekeeping for monitoring remote access within your environment. So defining the scope. The scope defines the physical or logical group. So what's this use case going to apply to is really what you're asking yourself. In our case, it's everything, and that'll probably be a lot of cases. When you look for people clearing logs, you don't just care about a specific office, but you may be sending alerts to different people, and in that case, you would have a more granular scope for that. So what event sources are needed? I've already covered this. 4624 is a Windows logon. Type 10 indicates remote interactive. One thing to keep in mind that a lot of people don't consider is that there's Windows audit requirements that need to be enabled so that you can even log these events. So you see log on, log off, and you want to be logging successful logons, and that'll generate those events. These events will occur on the log sources that you're getting, so that's something else to keep in mind. And here's just kind of an example of the local policy editor. So this is where you change these. So in the advanced audit policy configuration, Windows 2008 and above has a pretty granular ability to log different items. So we're going to talk about validation. This is probably where most of the work goes in when you're doing baselining. So during this phase, event sources are validated. You want to make sure that the events are coming in, that you're receiving them in a simple use case. And common problems will include like non-uniform audit policies. So for example, you might have audit settings on one domain controller that have been applied locally, but not across all your domain controllers. So on one, you might be getting logon success, and on another, you may not. So having a very uniform policy is very important. Incorrect audit policies. So you may have the same audit policy across your environment. They're just not set to collect the information that you need. Configuration issues. So that might be, agent installation, credentials that need to pull the logs, and then logging infrastructure. So if you send all your data through syslog, but the firewall blocks syslog, then you're obviously not going to get the data. Maybe you have syslog enabled everywhere except for your DMZ, and in that case, it's blocking the data. So that's something else to think about. But in our case, the exploratory data analysis occurs in the validation phase. So determining whether the data is normally distributed, determining whether it's going to make a good use case for, and what our thresholds are going to be. So here, again, I've plotted RDP data on for a 30-day period per day. So per day we see on day 20, we see almost exactly on the average, and so on. Again, this data does not look heavily skewed. So you see kind of the same data above and below the average here. You see most of the data lies in this band, and it kind of as you go out, you see less and less. So just off the top of my head, you see it looks pretty good. But when you look at the data, 93% of the data is within 2 standard deviations, 70% is within 1. So that closely approximates our 3 sigma rule at 68, 95, 99.7. So take a look at the histogram. The histogram looks pretty symmetrical about the mean. So there's approximately the same amount of data above and below the average. But again, it's hard to say, but I think this is a good candidate for that. And finally, the Shapiro-Wilks test that we talked about again. I fed the RDP count per day. We see that the p-value is 0.39, which is far above the 0.05 value that kind of rejects the hypothesis that this was not taken from a normally distributed data set. So we're pretty good. We think that this is normally distributed, and we can start creating some thresholds. So the point with creating thresholds in the logic section. So we're going to find the exact details used to generate the desired output. So in the case of clearing logs, it'd just be that event. In our case, it's going above, the quantities are exceed or go below our thresholds. So for this, we're going to use 2 standard deviations. So 95% of the time, the data should be well within that range, and 5% will get an alert or some sort of alarm. So the actual logic will be, we're going to compare the current value for yesterday to the baseline that was generated from 30 days prior to that. And if that's above or below the data, we're going to send an alert, essentially.
Question.
Yep.
Would you want to pick 28 days so you have the same days a week?
Well, they're all weekdays, so I'm not worried about it. Again, this is only weekday data. We're baselining, in our use case, we're baselining weekday data. So that's a good thought, because if it included weekends or significant changes, or if the data changes on a day-to-day, maybe Wednesdays are always big, Mondays are always low, and Fridays are always low, it may not be a good choice to baseline all weekday activity. So we're going to talk about the implementation and testing. This is where you actually implement the use case, you create the thresholds needed, and you define the output. The outputs can really be an email. You're probably all familiar with email alerts, reports. It could be a dashboard event. Maybe you have a running tally on your dashboard. Could be just a new generated security event to be used with another rule. So maybe you have rules in place for, if so much weird activity happens for a specific user, we're going to trip a bigger offense. So, and there's probably others that I'm not thinking of, but I think you get the idea there. And finally, defining a response. This is a big issue, right? Like, what do you do with the alerts? So during the use case development, you need to figure out, what are you going to do with this? So create a formal response procedure. And this is good in a document. Companies always like documents, and having a use case catalog really works well for showing, what you're doing on a day-to-day basis, how you're managing that. And I've given that to auditors, and it's worked very well for defining and proving that you're actually doing the work that you want. So for RDP logon investigations, for me, I would have a list of questions I'd provide. I'm saying, I'm going to look to determine if the RDP logons appear to be a threat. That's what you're looking for. Is this an administrator, or is this somebody with compromised credentials moving laterally throughout your environment? And you do that by, are the logons at a time for that user? So you see a user, you see maybe it's the network administrator or the network manager, and it's on a Sunday at 2 a.m. That may or may not be normal for your environment, so that's important to understand. Are there a large quantity of unique destinations? So are the user, are you logging into one server repeatedly, or all the servers in your environment? Should that user be logging into those servers? Are there single or multiple sources? How long were the sessions? Were they logging on, looking for something, then logging off, or were they logging on and doing a variety of tasks? What processes were ran by the user? Were there single or multiple users? Was it one specific user, or maybe there was 10 new admins hired and that just increased the threshold? And finally, are there any major operational activities? So I would include these as part of my investigation for this specific use case. I think it's very important because, I think someone said earlier, you got to ask yourself why we're doing this, and you don't just do this for fun. Or maybe you are and you just want to put it on a nice dashboard at the top of your SOC or something. And finally, the maintenance. This is going to be a little bit more involved for baselines. But the maintenance is really, every use case needs to be maintained. And I'll find that organizations will have rules, but they don't know if they've ever triggered or whether they're triggering properly, if they're correctly configured, if they're even applicable anymore. So this is where you kind of look at those questions. So just evaluate the use cases on some sort of interval. So every month, every quarter, semi-annually, annually, take a look and say, is this still applicable? Do I still want to even use this? Do I still need baselines? This is also where we identify and handle kind of outliers and just determine that in a baseline, is the data still normal? Like I'm showing 30 days, but in a period of 180 days, that may change. It definitely will. So for this phase, we're going to primarily focus on monitoring the health of our baselines. And you do that by evaluating the data the same way that we did before. We're going to take a look at a bigger swath of data and just see, is it still normally distributed, and is it still relevant? So here's a graph. If you recall the p-values, if it's over 0.05, we can say that it's probably normally distributed. So here's a graph every day that we generate a baseline over a period of about 101 days. So there's 101 baselines generated. We're graphing the p-value. So anything above this line is good. Anything below this line is bad. We see that there's 73% or 73 of them are from good data sets, 28 are not. So there's a period here for about a month where the data starts to change and it doesn't look good for creating the baselines. When that happens, you're going to start to get more alerts, and that's really the worst case scenario. You're going to get more alerts than you really should. You're going to get more than that 95%. So here we see during this period, these baselines were not relevant. Here's the data that contributes to those baselines. To me, when I look at this, I see a clear breakout about this point. And this point happens to be about 30 days. So now we start seeing what appear to be outliers at the time are actually normal. And what happens here is there was more RDP logons due to, this could have been done due to new admins. Maybe there's operational procedures that they had to do, like there's a big patching push. Everybody had to log on and start patching the products. But what you notice here is that after a while, this data it's still up above, but this data becomes normal again and it's still relevant. So during this phase, you're going to ask yourself, can we even still create these baselines, and are they working for us? In this case, it does deviate, but it gets and it comes back to life, I would say. So you'd still use this data and it's still relevant in my opinion. And you're really just going to get more alerts during that period of time. So during the phase, you're going to decide how to handle these data changes. In this case, I would leave the data. These are probably naturally occurring. I did not investigate, so really the first step would be investigate and ensure that these are naturally occurring, and not somebody not a compromised credential that's been in your network for. It could have been an attacker there for a month, and then they finally patched all their systems. But in this situation, it's a clear breakout, so I'm not worried about it. But you have a couple options: accept the deviations and wait till it recovers, remove those outliers, or scrap the use case in general. If it becomes too chaotic, you're not going to be doing yourself any favors by investigating alerts, every day that are just wild goose chases. So we're kind of wrapping up here, and summary is pretty straightforward. Identify the data, make sure it's normally distributed, and you can use 2 standard deviations as the baseline. The use case, the high-level use case for this regular outlier detection, which is what we went over. So if you're SIM, you're managing these thresholds. That kind of falls into that category. Proactive investigation and hunting. So you get into a network for the first time and you're trying to see if there's funny activity going on, that you can start using thresholds to determine, hey, is this normal activity? And then just general environment exploration. So you're new to a company, you want to figure out what's normal on here, what can you create rules on, what makes sense and what doesn't. So during this presentation, I thought at the start, I thought it'd be very easy. And as I'm going through all this stuff, and I'm thinking, man, we could really push this. So I mentioned a breakout detection, or I mentioned a breakout. Well, there's a Twitter GitHub package for breakout, automatically determining breakout detection statistically. So you can see that there was a breakout and handle that accordingly. Automatic outlier detection. So there are some strategies for determining outlier detection, but nothing, no specific guidelines. But maybe coming up with automated outlier detection and a way to accept or reject those outliers. And then non-parametric analysis. So if your data, like a stock market, will trend up, but it'll deviate up and down, that will not follow normal distributions, but there's still ways to analyze that. And you can use a package like the Twitter anomaly detection. For my intervals, I use 30 days. You might be able to find better intervals for that. And really, with the goal of determining or having the least amount of outliers and alerts while still remaining statistically relevant. And then additional use cases I'd like to go through. So I covered 2. They're pretty basic, but there's probably some really cool ones that could be applied. So I'm going to be exploring that. And then finally, kind of looking at multiple baselines. So if you have 10 baselines that apply to each user and you're mapping their activity, you could create a sort of a weighted system and determine which user is showing the most anomalous activity and then investigating that user. So one user might often trip one baseline, but if they do 9, that's something significant. You need to look into that. So kind of investigating how we can stack those baselines to really look for global anomalies for specific users. Here's some references. So like I said, I really like the Logging and Log Management book. If you're interested more in the Shapiro-Wilks test, I definitely recommend InfoSec Nirvana for the SIM use case. It's high level, pretty straightforward. There's nothing difficult there. And if you're interested in the anomaly detection and breakout detection, these are easy packages. You're just feeding it a list of quantities, and it'll graph that for you. And then threadhunting.net if you want to take a look at additional use cases for evaluating outlier and baseline detection. And that's about it. Do we have any questions?
Hi, thanks. Good talk. I'm going to ask maybe the most obvious question. What if it's not normally distributed? What if it's like a fat tail or something like that?
Exactly. So that's where, like I said, this will only work on normally distributed data. And you can take a look at a package like anomaly detection. You have to look at other methods, and that's something I have not explored. And there's a lot of data like that. For example, during the investigation, I took a look at account lockouts. And in many organizations, account lockouts won't happen at all. So your most frequent event's going to be at 0, and you're going to only see a tail that'll go down. And that's not a normally distributed data set. So you'd have to look at that in a different way. So depending on how that is, you could only have an upper limit, or take a look at some other methods. So I haven't gotten into that, but something I'm definitely going to explore further.
You talked about having a petabyte of data. I don't know how big your user base is, but what are you doing for audit log reduction?
For log reduction?
Yeah.
Compression? No, I don't know.
No. I mean, it's like filtering out the data you're
Yeah, no. So we're kind of getting to my daily work, but for most SIMs, you have 11 to 40 terabytes of data, and that's compressed after some sort of interval. So for most organizations' use cases, from a small or medium size, 40 terabytes will store a significant quantity of data, more than they ever really need. So I'm not usually worried about reduction. But if you're looking at log reduction, things like looking at your audit settings, following CIS benchmarks, right? They say, here's how your audit configuration should be. And you can start tuning those to turn off stuff that you're not using. There's also different methods, so they call it output-driven logging. So if you have a list of use cases, what events do you need, and only logging those events. But then if you need that for forensic investigation, you may need additional events that are not part of that. So there's multiple techniques. It's not something I typically worry about because I haven't had to. Storage is far more than I need, usually. So.
Instead of drawing sort of like a mean on a graph that involves both the weekends and weekdays or other sorts of like predictable anomalies, I guess, like that, do you think it makes more sense to be separating them out and then only evaluating the data, for example, on weekends on a weekend-only graph, et cetera, so that you don't have to be constantly looking and then maybe you miss a dot that looks like it's a weekend dot or things like that?
Yeah, absolutely. So I think we're covering, so you're talking about like, going back to one of the very earlier slides. This one. So like this one you're kind of talking about, I think. And I didn't really know that these were weekends at first. That was just the first thing I thought. So you kind of determine that through the exploratory analysis. And in some instances it may not change from weekend to weekday. So you need to figure it out. But once this data right here, let's cover it. This data only contains weekdays, so I kind of do spread it out. And I just don't go into the baseline for a weekend, but you do the same exact process. So just for brevity. Yes?
Really quick, is that all Windows events or just the 4624?
These are, in this case, it's all Windows events. In my other graph, it's only the RDP logons. So if you see, this is really 12.5 million, which actually isn't that much, but it's pretty stable there. Yep.
This is more of a comment than anything else. If you start looking at autoregressive and moving average models, then you'll be able to actually incorporate those weekends into the baseline that you use.
Because so that's a good point. That's something I'd definitely like to talk about anybody if they got some ideas on these, because this might be rudimentary and there might be some better options. So I think like looking at 7-day moving window kind of thing, is that what you're talking about?
Well, autoregressive models essentially they take each. So if you do a 7-day thing like that, it will normalize it for that 7th day.
Okay.
Or 7 days back or so, and it'll help remove some of the seasonality out of your data.
That's interesting. Yeah.
Okay.
And if you look at the Twitter packages, the seasonality is a big one with these because depending on your environment, it could change from season to season. I think the Twitter package uses the ESD algorithm for its, which accounts for seasonality and things like that. So I'll definitely look into that. Okay.
I was wondering if you could tell me a story so you showed basically looking at two styles of events here, the Windows event and the RDP. Did your looking at that data, when you initially set that up, did you find incidents to investigate further with those
No.
looks, or did you have to then use those same?
Well, kind of. So I was unsure about that Friday with the dip, right? So that's one thing I did check out, and this one as well, right? So I looked into that, and the audit settings were changed between this day and that day. So that's something that I could tell. We do take a look at account lockouts. So I've seen in my past like companies that allow RDP externally. They didn't put a host behind the firewall. All of a sudden, accounts were getting locked out left and right, and surges in the account lockouts indicated that. And when they went and investigated it, it determined that the appropriate preventative controls were not in place. So that's another story. There's plenty of stories. So in my past life, monitoring. So I used to look, but I'd only look at surges within the time series graph. I was not analyzing it like this. But I would see severe spikes, and then the EPS would baseline. It would just stop, and then it would start falling behind. And logging configurations on the Cisco IDS modules for a client I used to have at my old organization was incorrectly configured and was trying to pull down patches, and during that was constantly generating DNS requests and in a highly secure network. And that actually led to cameras being taken offline. So determining that, we nailed down the process, we're able to fix it, and we kind of used trend analysis for that. It would be better if we could have more quickly determined that and had a use case developed around something like that to quickly determine those thresholds. So, yeah.
Thanks.
Okay, I think that's it. Thank you.